A very warm welcome to you all. Thank you for joining us today in the second of our series of carbon webinars hosted by BCIS. My name is James Fiske. I'm the CEO of BCIS, and I'm also the chair of a pan-industry initiative called the Built Environment Carbon Database that we're actually going to be hearing about later on today. I'm joined by Fabrizio Varriale of the RICS, who I'll introduce a little bit later on, who'll be talking to us about the Built Environment Carbon Database and what that means for us now and in the near future. Before we start, we'll just do a little bit of housekeeping. Please feel free to ask any questions that you have throughout this webinar using the chat box. You'll see the little graphic in front of you. I'll try and get through as many of those with Fabrizio as time permits. As we found out in our last webinar, unfortunately, I talked far too much and we ran out of time far too quickly. Hopefully I'll be a little bit better this time. But what we will do is, even if we can't get around to your question today, like we did in our first webinar, we'll follow up with a recorded sort of Q&A, and we'll also continue and sort of answer and continue the debate really on the BCIS LinkedIn group, which is the web address that obviously is also on our screen. This session will be recorded as it was last time and made available on BCIS. So just in case you encounter any technology problems, and I think we did have a few, certainly with things like sound quality last time. So if you do, my apologies, but don't worry, you still get a chance to obviously view this and also ask questions that we'll pick up on LinkedIn later on after the event. As before, when leaving the session today, you'll be prompted to give some feedback. Please do that. If we're doing a bad job, or if I'm doing a bad job, please let us know. We'll make sure we get a different speaker in for the next webinar. Anything that will help us sort of refine and improve what we're doing here, that will be very much appreciated. Also, please let us know if there's any other topics that you'd like covered. Carbon is obviously one of the ones that you asked us about before, which is why we're running these carbon ones. If there are other topics that you would like BCIS to cover, then also please let us know on that feedback. So before we get into the main sort of topic of today's webinar, which is about carbon data, a very quick recap on part one. As I said earlier, the video is available on bcis.co.uk of the full webinar part one. I do recommend that you watch that before you watch this one if you can, because part one was really designed to try and get a common understanding. In our industry, we do a fantastic job of confusing ourselves with different terminology, different acronyms. So part one of the webinar was very light touch, very high level, but trying to get that consistent understanding of carbon data, carbon methodology. We talked obviously a lot in the first part about the RICS professional statement, and we ran through the various stages that you can see on the top right, the product, the construction process, the use, and the end of life. Obviously, we're going to be going through these again today as we're talking about construction carbon data, carbon data, because they do change in terms of the availability and where to get that data at each stage. On the first webinar, we also ran through a calculation example using a crude sort of cavity wall, just to show how you can calculate embodied carbon of things. I've had lots of questions since the first webinar on sort of carbon calculators. I've recently just put something on my LinkedIn sort of feed of something that I've written up in terms of where we are with carbon calculators in the UK. It's great to see so many carbon calculators coming out, but unless they get to the same, using the same sort of methodology and underpinned by the same data, I do have a concern that we're going to end up confusing ourselves even more. So if you do get an opportunity, have a read of that and let me know if you agree or disagree, and then we can think what we can do about improving that situation. Okay, yeah. So today is really about carbon data, and we have a big challenge here, like we do with the consistent application of the methodology, but for carbon data, unfortunately, unlike cost data, we don't have a very long, rich history of data that we can draw upon, and data is absolutely essential, obviously, in any assessment that you're undertaking. So today's sort of session is really sort of trying to draw out where that carbon data is currently available, and obviously what we're hoping to do as an industry about it through the Built Environment Carbon Database and some of the activities that BCIS are doing. So to start with, I just wanted to go back really to a question that was raised at the first webinar, when we were talking about an example of sort of embodied carbon calculation. So somebody asked, you know, what do you do at the early stages of a project when you don't actually know the materials that you're gonna specify? So therefore, you can't use an EPD, an environmental product declaration, for that particular product. So what I've tried to do, and hopefully it will work, but please let me know if it doesn't, is I've tried to draw up first of all the levels of information that will progress over the life of a construction project. So what we have to begin with is a very simple timeline. That timeline indicates the very rough stages that we go through on a construction project. First of all, appraising, then we go into design, and that design will obviously evolve and get into more and more detail before you commit to construct anything. You have that construction period, and then that operation, that in-use period that we talked about in the first webinar, that hopefully will be well over, you know, sort of 60 years. And then after you've run that thing, and it naturally reaches its end of life. So they're sort of, you know, very crudely the stages that a construction asset will go through. And what I've attempted to do here is show very crudely that the amount of information that you know at each stage obviously increases. So at appraisal, you really don't know very much at all. Once you get into design, you'll start off, you know, and as the design progresses, you understand more and more about what's going to be included within the construction asset that you're trying to build. And then there'll be a whole sort of construction period, and it's not really until actually after that construction period is completed and you've reached practical completion do you actually know all of the bits and the components that were actually used in constructing that asset. And of course, after you've operated the building for, you know, 60+ years, you'll then start to gather all of the in-use, that operational maintenance and renewal type data. And it's only that, you know, after you've got all of that, do you truly understand what the whole life carbon or cost of the project actually was. So what do you know at the very early stage? Well, this will obviously, this is a crude generic approach. This will change project to project, but I'm just trying to get over sort of the basic sort of principles here. So at an appraisal stage, you're likely to know, you know, things like hopefully the asset type, i.e. what's its functional requirement, i.e. it's a hospital, it's a school, it's a warehouse in the southeast. Well, you know some basic principles about it, and you're also likely, I would hope, to know some basic functional requirements at that stage as well, which could be a size, it could be a volume, it could be a number of desks, a number of beds for a hotel, whatever it may be. So at the very early stages of a project, you don't know much more than that. You certainly don't know what material, manufacturers, components you're going to be putting into your construction asset. As the design sort of progresses, you'll be into elements. You know, should it be a flat roof? Should it be a pitched roof? And lots of sort of conditions of planning will start to be included at this stage. So at this stage, you're starting to get a sense of the elements and the systems involved in your asset. Obviously, as the design progresses, you'll then get a bit more system sort of detail. Maybe some product performance specs will start to come through at this stage, or maybe a little bit earlier, perhaps. But you'll start to get a sense of, okay, right, we're going to put an air-conditioned unit of this kind of performance. We're going to have a thermal performance of XY. You'll start to know more information at that stage. Probably not down to the exact manufacturer of things, but you'll roughly know the performance that's required of the components. And then at getting near the end of that sort of design stage, that's where you'll either have sort of product performance sort of specifications, or even manufacturers that are specifically specified. So it's at that detailed stage when you'll really start to understand the manufacturers, or at least the types of products that you're going to be putting in. Obviously, after the thing is built, you then have all of your as-built information, and then obviously at the end of the in-use period, you'll have your actual whole life. You know, how many times did you maintain? How many times did you replace? What was the operational energy use? What was the water use? Etc. etc. So you'll start to get that actual data. Today, I'm just going to focus on the sort of appraisal and design stage. In an ideal world, obviously all of that as-built and actual information would feed into industry databases, so that we have a better understanding and a richer source of data sort of going forwards. But today I'm just going to focus on sort of the appraisal and design stage, and the typical bits of carbon information, where that's available. Before I do, another important thing just to note is that in the cost world, we have a good sense of the early stage of a construction project. The estimating, the accuracy of the estimate is very low in terms of its accuracy levels. Typically, we'd be looking at sort of plus or minus 50% sort of accuracy from a cost perspective at the very early stages. If it wouldn't take too long for you to Google certain construction projects that would be quite happy with that level of tolerance. But the point is that at that early stage, where you don't have all of the information, there is a big tolerance associated with how accurate you can actually be. And the concept of the funnel is, obviously, as you understand more information about your project, you're able to get your estimate more and more accurate. So that's a concept we've worked in the cost world for quite some time. The same thing, of course, applies with carbon. Now, because we don't have that rich historical sort of data set, we can't be quite sure whether it's a plus or minus 50% likely at the beginning, or whether it's even greater. And I think only time will tell. Now, I know the RICS are trying to look at this in their updated professional statement. So hopefully they've been able to sort of come across something that certainly I'm not aware of at the moment. Okay, so looking at carbon data, what I thought we'd do is, if you look at the top right of the slide, we've got this module A, B, C, and D that we talked about in our first webinar. What I thought would be useful is actually if we broke into each of those stages, each of those modules, and talked about what carbon data is available at the moment at each stage of the construction project. So if we just focus on the product stage, so obviously that's the creation of the actual product itself. not the installation or the transportation of that to site, which is obviously our next stage. But if we look at those stages, and again, as I said, I'm only focusing on the appraisal and design sort of part here. What kind of information are we likely to be able to use or need at each of those stages? So at appraisal stage, because really you only know what type of building it is and perhaps some functional parameters, you can't go into EPDs, you can't go into generic EPDs even. What you will have to call upon is historical project data, like we do in the cost world, and that will be the equivalent of our cost per meter squared or cost per car parking space type data that we have in the cost world. We need that for the carbon world. So, but obviously it would be kilograms CO2e per meter squared or per hospital bed or etc. car parking space, whatever examples I used. So we need that very, very high level information, and we obviously need to also consider that we had that estimating accuracy funnel earlier. So our historical projects will obviously vary. So at this stage, we should be looking at, in my opinion, sort of a 3-point estimate, or at least a range of data that we can say that our building is likely to be between sort of this number and this number kilograms of CO2 per meter squared or per car parking space, etc. As we get into more data, obviously we can then start to substitute some of the generics with a bit more detail, and that will continue throughout the whole sort of design evolution process. So we're gonna need the elements and the systems type data that we do in the cost world. What's the typical carbon per meter squared of your flat roof as opposed to your pitch roof, your concrete frame versus your steel frame, all of those sorts of things. So at this stage, you're going to have to draw again upon historical projects, because our building hasn't been designed yet, so we don't quite know what that frame looks like or that roof looks like. All we can draw upon is that historically, a building fulfilling this sort of function, having this type of element on it, would range between X and Y. So again, we need a historical project sort of data at this stage to draw ranges. As we again continue through that design process, we can then probably move more onto generic product data with approximate quantities, in the same way as we do in the cost world. We start to understand roughly what kind of quantities as that design evolves, typical kind of products and maybe still systems at that stage. What do those things kind of look like, and then obviously nearer the end of that design sort of process, at that stage you're gonna need more specific product data with measured quantities at that stage, rather than sort of approximate quantities. So what kind of data is available? So at those sort of early stages for our product data, the historical projects, so the RICS Buildings Carbon Database, which I think is probably switched off now as we prepare for the launch of the Built Environment Carbon Database that Fabrizio will be talking about shortly. There's various industry guidance in places like RICS. Leti have done some fantastic work pulling together lots of data, so I recommend you sort of check out some of their stuff. Again, iStructE has done quite a bit of work, really good work in this space as well. So there's sort of various industry guidance sort of giving you carbon per meter squared type levels for various buildings. Some commercial software does also hold bits of data. One example I put in there is One-Click LCA. And there's also quite a bit of research that's been done by, if you Google, there's European studies of embodied carbon on buildings and other sorts of research activities that have been released and in the public domain. Obviously, confidence of those things I can't comment on, but yeah, you'll need to consider the confidence of those projects, you know, how they were derived, what they include and what they don't include, because there is a risk that some of that historical data obviously doesn't comply with the methodologies that we're all working to now. So just a note of caution there. Keep your eye on that. In terms of the, you know, the more detailed design data in the product space, we've got. So if you remember in our first webinar, we broke into sort of product emissions and quantities as two bits of essential information that you need in order to quantify the embodied carbon. So in terms of the product emissions database, the prime source is obviously EPDs that we talked about before, the environmental product declarations. Part of the challenge is that they're not necessarily available in one place. I think we're getting a little bit better in the industry. There's also a bit of a challenge in terms of when you do get hold of them, they're not all of the mandatory fields are completed in EPDs. So and sometimes really important information that you need in terms of a unit of measure, it's really hard to try and find and extract. So you've got sort of EPDs that are available sort of around a few sort of places. If EPDs aren't available, obviously you've got your unverified EPDs, your other LCAs, and even estimated sort of values. So part of the challenge is that they're just not available in a central place at the moment, and you'll spend quite a lot of time sort of looking and searching, which is why the Built Environment Carbon Database is much needed in the industry, and Fabrizio will be talking about that shortly. So you also have, you know, perhaps one of the most commonly used one is the Inventory of Carbon and Energy database, where we're BCIS are currently working with Craig Jones on the update, because that's also going to feed into some BCIS data sort of going forwards, as well as the Built Environment Carbon Database. But I'll talk to you about that at a future webinar. Commercial software also is, you know, one-click LCA as an example, also has quite a bit of data within it as well. In terms of quantities, those quantities are available. You can get sort of generic quantities from the likes of the BCIS scheduler rates, and I'll show you a screenshot of this in a short while. But you know, in an ideal world, you'd obviously be using material schedules, bills of quantities to understand the quantities of those materials. Now those you know, bills of materials, material schedules aren't going to be available until probably a little bit later on. So in the absence of that, there is generic information from the likes of BCIS that can support your calculations. If you haven't seen the scheduler rates, don't worry, this isn't a big sales pitch at all. It's just really just trying to highlight that it's available. It's available. So you can go through activities of work. You can drill down into the activities of work, and you can get labour, materials and plant build-ups for all of those activities of work. So you know, you can start to get quantities of materials, and even things like plant, which isn't important for this section, but is important when you're looking at the installation and construction emissions, which we'll be doing shortly. So yeah, the BCIS scheduler rates gives you some of those generic sort of quantity data that you will need in terms of your calculation. Okay, moving into the construction, installation, transportation sort of process. So yeah, this is where you're transporting your product over to site, and then you're installing it into your building or construction asset. So again, following the same sort of process as we had earlier. What have we got what can we use at the early stage? Well, you're not going to have specific transport planning data available for your project at an appraisal stage. So all you can use really is the data from historical projects on what's the typical transportation routes and quantities of transportation, and also the on-site sort of emissions. So you're going to have to, at that early stage, just rely on historical projects again. As that design sort of evolves, you're likely to have some generic data, but it's only until the latter stages of that design process that you're going to have any specific sort of installation information and transportation data that you'll be able to sort of build into your calculations. So what have we got? Well, we've got averages from the RICS professional statement. We covered this in our first webinar. The BCIS schedules that we talked about earlier has typical installation rates, how long an excavator needs to be on site, or cranes or whatever. All of that sort of information is available in the BCIS sort of schedules, as well as eventually, as you get to the more detailed design phase, the project activity schedules and bills. Likewise with sort of transport, you can only really use the averages in the RICS professional statement until you know what materials you're using and where they are going to be available from. There's a project that BCIS is working on, which is a materials database, which I'll try and touch on later if we've got time. That is at some point going to include where the materials are available from. That should help some of those transportation sort of calculations in the future. But in the absence of that, we have averages of transportation sort of routes from the RICS professional statement, and then you can only start to map things once you know where things are available from and how long it's going to take to bring them over and what route you're going to take, etc. So the known transportation calculations is a bit of a challenge for us, certainly, and when it comes down to the carbon data at the moment. This is again just another screenshot sort of showing the scheduler rates. Apologies, I said I wasn't going to do sort of a sales pitch, and it sounded more like it's a sales pitch, so apologies for that. But yeah, an example of sort of the construction plant that's used on site, how long it's used for, that you can actually build into your calculations. So rather than using this generic numbers, which are great in the absence of anything better, of course they are. But the truth is that if we truly want to know our whole life carbon emissions, we are going to have to think about how we're actually installing these components together. What on-site sort of plant are we using? What kind of fuels is that thing burning? How long is it going to be burning them? What's the emissions caused by that? We do need to start thinking about it. But I appreciate that at the early stage, you don't know any of that, so you have to rely on those sort of generic numbers from the likes of the RICS professional statement. Let's move on to in-use data very quickly. So again, we're going to be limited at that early stage into data from historical projects or guidance, and then as that design sort of evolves, again, generic data slowly being substituted by specific in-use data that's been sort of calculated or plotted from the design teams. So yeah, at the early stage, there's a lot more data out there now on operational energy. So when you're looking at your operational carbon, likes of SIBSI and other places have quite a bit of data on operational energy. BCIS also has energy in its lifecycle costing data for various buildings. So at an early stage, when you don't quite know what it is, how thermally efficient it's going to be, how you're heating and lighting it, you're going to have to take industry sort of averages. Obviously, that will become more and more accurate as you go through that design process. You obviously need to know the maintenance, replacements, the repairs, the refurbishment activities that need to be done on the thing over the life. on that construction asset over its life, and you're not going to know that at an early stage. So all you can do is again use that sort of historical data. But as things become more known and specified, then you'll have to go through a process of working out those. What are the maintenance activities? How frequently do we need to undertake those maintenance activities on each of the components? What's the quantities of materials that we're talking about? What are we taking up and disposing as we're maintaining or replacing component parts of our buildings? And what is the emissions of the materials that we're putting back in? So there's quite a bit of calculation at the in-use stage, where you can get hold of, and we've covered some of these already in terms of sort of the emissions of the materials and the quantities of materials and how you can calculate those. Yeah, one of the biggest challenges is actually understanding what are the maintenance, replacements, repair and refurb activities actually are on those components. Even at a detailed stage, we do struggle a little in our industry to do sort of life cycle costing because of those things. Now we're talking about whole life carbon. We're also going to have to do this for carbon as well as cost data. There's a couple of bits in BCIS that can help. So the life expectancy BCIS component life gives you those frequencies of replacements. So unfortunately, I think my video is probably right over the interesting part. But you go through and you can select a sort of a building component, and then you can see how long that thing lasts based on the BCIS sort of historical data. Give you a minimum, a maximum, and a typical. So at least that gives you some basis of that frequency. So we know we're going to have to maintain or replace this thing, in this case, every 30 years. The other thing that BCIS has that can help is our component life cycle evaluator, that we call it. And what this does is it gives you the ability to select common construction components. Like we've done down here, you can select a quantity of those things. For each of the components, you can then drill down and see what activities need to be undertaken on that component. So in our examples here, I think we've got curtain walling system where we've got asset replacement happening, on average every 42 years in our particular specification. We've got cleaning obviously happening a little bit more regularly than that. We've got inspection, we've got planned maintenance works and reactive maintenance. All of those have sort of frequencies associated with it, and each of those also has a labour, materials and plant build-up. So with Lifecycle Evaluator, you can go through and you can select and quantify your components. You can ask the system to give you your cost, as in lifecycle cost, CO2, which obviously we don't do anymore, so that shouldn't even be there as an option, to be honest with you. And CO2e, you can select the number of years for your reference service period, your study period, sorry. What typical usage. And then based on those things, and you can set net present value and all sorts of other things in the life cycle costing world, that will quantify based on all of the materials and the frequencies of the activities and the on-site emissions. That will quantify the embodied carbon of the components that you've selected. So that's been around sort of about 3 years. We are looking at trying to improve it and making sure that it can report out to the RICS professional statements. There's some ongoing work that we're doing at BCIS to make sure that that becomes even more useful, hopefully for the industry sort of going forwards. Okay, enough of me prattling on, so my apologies. I'm very passionate about the subject. I make no apologies for that, but I do apologise that I'm taking up too much time. So I'm going to hand over to Fabrizio Varriale. Fabrizio is from the RICS, and I'll ask Fabrizio to obviously introduce himself as he takes over. Fabrizio is going to be talking to us about the Built Environment Carbon Database. So I'm the chair of the steering group of the Built Environment Carbon Database, and it's actually BCIS who's funding the development of it. The concept of a shared and open data library is a great one, but I've been in so many conversations over the last few years about well, can we get the government to fund it, and can we do this, and can we do that? Nothing ever happens. So BCIS is actually funding the development of the BECD in terms of its sort of technology, and lots of the industry are giving up their time free of charge to get this thing to happen. So look, I'm hugely excited by the BECD, but let's hand over to Fabrizio, and Fabrizio can tell us a little bit more about it. Fabrizio, over to you.
Hello everyone, I am Fabrizio, analyst at RICS and member of the BCD steering group. In the short presentation, I will tell you about the concept behind BCD, how it works, and a little bit about the timeline. As James was saying, the Built Environment Carbon Database is an industry initiative which is led by a consortium of professional bodies and UK organizations, which you can see there, their logos. How this came together in autumn 2020, RICS and AROP, we had a workshop with various industry representatives to try and understand what are the industry needs in terms of data for carbon assessment. Later, we put together the steering group of the BECD and started working on the concept. And then we put together two different working groups to work on the two sections of the database, which I will talk about in a moment. The objectives of BCD is to effectively establish the official UK repository of whole life carbon data on the built environment. And that will help to harmonize and streamline reporting of carbon assessment. It will increase the availability of free data. It will also increase transparency and data quality for all data, free and paid. And it will also align and strengthen the RICS professional statement whole life carbon, the current version, and the upcoming updated one, as well as with the net zero carbon building standard. The concept about BCD is important to understand that it is a data repository and not an assessment tool. It doesn't do your calculations for you. It is capable, or it will be capable, to import and export data to and from existing software applications that are being used to do the assessment. It will work to a basic account, which is free to access, where you can report and retrieve carbon data. And might implement at a certain point a pro account that you have to pay for to do some advanced filtering and benchmarking. But it's important to understand that the raw data will always be free to access. Now, BCD is really two separate databases. The first section, which is dedicated to assets, meaning projects, covers both buildings and infrastructure and covers embodied as well as operational carbon. The second section of BCD is about products, and so it will contain environmental product declarations and other product lifecycle assessments. Now, for the asset section, again, it covers both embodied and operational carbon, with the option to enter one or the other. It will allow project stage tracking, means that you'll be able to add more assessment as the project progresses. The users will be able to enter the data manually or through a semi-automated input, meaning, again, they will import data from assessment software. You will be able to share a project between different users so that they can enter different parts of the data. You then will be able to, with the outputs of the database to look at your project and compare it against similar ones. And obviously, you'll be able to export your data as well as the data that's in the database at large. That scheme there just gives you an idea of how the database is structured. You create an asset, which is a building or infrastructure, and you associate a number of information attached to that. And then you will associate potentially infinite number of assessment to each asset. And to each assessment, there's another bunch of information which are attached to each. The key information, which is really details about the information, materials and embodied carbon figures, as well as operational energy and carbon figures. For the product section instead, this is effectively a catalog of existing LCA for construction products. It will only hold basic information about each LCA record. It will not replicate existing databases, but rather bringing them together. So the users will be able to search the records and do a filtering function to look at the type of data that they're looking for. They will also be able to submit new LCA data that will need to be approved by the administrator. And again, the idea is that we bring together different existing sources that are out there, such as the EPDs that are sitting on your portal, other EPDs that might be elsewhere, the benchmark from the inventory of carbon and energy, and then existing academic LCA as well as professional LCA, but also referring to records that exist in paid databases.
Thanks, Fabrizio. I think that's excellent. Hopefully, we can all see the value of what that will be doing for the industry. So I urge you all to get involved. You can register your interest, obviously, on becd.co.uk. But this is an industry-wide problem. We all need to get behind it, and we all need to support. I urge. The industry needs to come together on this. It can't keep trying to solve things in remote little pockets. We have got to come together. We need a single methodology and a single data set that we can all get behind, so we can start to get a bit more consistent whole life carbon assessments and make sure we're driving the right decisions on our construction projects. Before we get into the Q&A, I just wanted to highlight that so BCIS has a plan of pulling in the BECD data into BCIS so that you can start to get cost, life cycle cost, carbon data and duration data all sort of together across all of the areas of BCIS. Now, this won't happen overnight, but one of the things that we're working on at the moment is a materials database, which we think is much needed by the industry. So the concept being that you sort of type in a keyword, you select a specification, you can then select one or a few different options and basically view some information against those materials. And the types of information that we're looking to pull together is obviously the cost, which BCIS already has, life expectancy that obviously BCIS is already plotting and monitoring, but also interesting things like, well, what happened to the price of this thing over the last 12 months? What's the forecasted price over the next 12 months? I.e., if I specify this thing now, am I going to have real problems in terms of trying to pay for it? Similarly, lead times. Is this thing available? Is there a 16-week sort of wait before I can get this thing on site? So lead times will be something that will be coming in, but also things like size and weight of the product, which is really important when it comes down to trying to work out your transportation calculations for carbon. That type of data, I hope, will help us improve our accuracy of transportation sort of emissions going forwards. So yeah, sort of a high level view here with some of the embodied carbon and various information coming out from the BECD. So I won't talk any more about that, but obviously we'll have a future sort of webinar talking about some of those things that BCIS are trying to produce. Okay, so a quick summary, and then we'll move into Q&A. Now, this is a massive thing for the industry. I'm not going to keep banging on about it, but this is super critical that we all act now. Reducing carbon emissions should almost be the first thing that we're talking about when we're sitting down with our clients. It's our duty to the planet, to the future. That we do something about this. Our first webinar talked about methodology and the importance of having that single methodology is really important. If not, we're just going to be calculating things in different ways and not drawing the right conclusions. Today's session very much about consistent data. We've heard a little bit about the pockets of data where they're available at the moment, the plans for obviously the upcoming release of the Built Environment Carbon Database, and hopefully how that will help us, and also a little tiny sneak peek of some of the things that we're trying to do to link cost and carbon together in the BCIS world. So the alignment of cost and carbon measurement and reporting will be the focus of our next webinar on carbon, and that will be available later this year. I won't commit to a date yet because we're just trying to finish off a few developments so we can show you some of those things later on this year. So yeah, look, thank you again for joining, and apologies that I've hideously gone over time again. My last urge to us all is that we need to come together on this. We need to share data, we need to learn from each other in order to drive future improvements. So we can't just talk about doing it, we actually need to do it. So yeah, thanks again for joining. Right, let's move on to the questions, because I've gone hideously over time again. Fabrizio, I think there's a couple of built environment carbon database questions. There's a lot of questions here. Fabrizio, what I'll do is I'll hand over to you. Do you mind taking those top two sort of built environment carbon database questions, and then we'll follow up, I think, later on with answers to some of those other questions that have been posed. Fabrizio, I'll pass over to you, please. Thank you.
Now, the first question that's asking what is the difference, to explain better the difference between BCD and a life cycle assessment tool for buildings. I think that's a key point. The key difference is that assessment is different from reporting. Assessment, it's done through probably a software tool, and reporting is done after the assessment is finished. So in a typical workflow, a professional might be using a software tool to do their assessment of the building, and once they finish, they will come to BCD and then report that data. In a similar way, we can make a comparison with how the EPC system works. So the EPC is done by an assessor through a approved software, depending if it's residential or not residential, and then eventually they are required to release and publish the results of that EPC, and that is stored on the EPC platform that you can publicly see. The difference with BCD is while the EPC or the background data is not really accessible, in BCD it will be, and so you'll be able to see what assumptions have been made, what type of materials have been included in each assessment. There's a second question, which is about will product but also project data that's entered by users be validated in any way? And my answer is not really, not entirely, though we will be doing some checks. We are not able to effectively do a third-party verifications because that would be an entirely different job in a sense, but we will be able to do some checks in terms of looking at carbon figures that are incredibly high or low compared to the averages, and those might be flagged up to the BCD administrator, and then at that point they can go back to the original user and understand why the figures are that different. Again, people will have full visibility of the data that's behind an assessment, so they will be able to see and understand that there might be something that's been done wrong or why some figures are particularly high or low. We will be also implementing some kind of confidence score that will give you an idea if that assessment is reliable or less. So if an assessment is, for example, fully aligned with the professional statement or RICS, then it will get a higher score in that sense. And finally, we got a question which is looking at to explain what kind of output for the asset section of BCD the user can get. This is effectively the output for the user. It's effectively all the raw data that's contained in the database minus the very few kind of sensitive information such as email addresses, etc. With this raw data, then the user is able to do their own benchmarking, which means that they can, for example, select a narrow pool of projects to then look at typical values. This means that you can look both at embodied and operational carbon, or looking at the whole life cycle value, but with much more detail than what is usually possible. For example, the user will be able to see minimum, maximum, average values for embodied carbon of an office building or of office buildings, but we'll also be able to drill down look at specific data sets that include only office buildings that have been assessed at a certain project stage, or project assessment that have been fully compliant with the professional statement, or for example, looking only at module A1 to A3 and only looking at the foundations of the building. So you'll be able to kind of slice the data set and understand and get the data that you want out of it.
Thanks, Fabrizio. I appreciate that, and sorry we didn't leave ourselves with enough time to sort of address some of the other questions. Look, thank you everyone for joining. We'll have to stop there, and as I said, I promise that we'll come back on any questions that we haven't been able to get round today. So again, thank you very much for joining. Really appreciate it. Please do spend the time to give us the feedback so we can improve things. Please, no comments on timekeeping. I'm fully aware of my lack of skills in that space when I'm talking about a subject that I'm very passionate about. But please do spend the time sort of giving us the feedback. Thank you again, and yeah, we look forward to seeing you at the next BCIS webinar. Thanks, everyone. Bye-bye.